morning, students. Myself, Dr. SWATI SHABNAM, Assistant Professor, Department of Agronomy, Birsa Agricultural University. The course title is Farming System and Sustainable Agriculture, and today we will be talking about conservation agriculture practices for sustainable agriculture. So, as we discussed earlier, if not practiced sustainably, agriculture can have a toll on the environment, produce greenhouse gases and contribute to climate change. However, sustainable farming methods can do the opposite, increase resilience to climate change, protect biodiversity and sustainably use natural resources. One of these methods is conservation agriculture. So what is conservation agriculture? Conservation agriculture technologies involve minimum soil disturbance, permanent soil cover through crop residues or cover crops, and crop rotations for achieving higher productivity. Conservation agriculture conserves natural resources, biodiversity and labor. It increases available soil water, reduces heat and drought stress, and build up soil health in the longer term. The origin of conservation agriculture, if we go through origin of conservation agriculture, the term conservation agriculture was coined in 1990s, but the idea to minimize soil disturbance has its origin in 1930s itself, and the concept was started in United States of America. CIMMYT pioneered no-till training programs and trials in 1970s in maize and wheat systems in Latin America. In 1980s, this technique was also used in agronomy projects in South Asia. CIMMYT began to work with conservation agriculture in Latin America and South Asia in 1990s and in Africa in early 2000. Farmers worldwide are increasingly adopting conservation agriculture. In the 2015-16 season, conservation agriculture was practiced on about 180 mega hectares of cropland globally, about 12.5% of the total global cropland, and which was 69% more than in the 2008-9 cropping. This table shows the global adoption of conservation agriculture system. The highest area under conservation agriculture is in USA. The next is Brazil and Argentina, both three countries in America and Latin America, and it constitutes 21.2% of total global area under conservation agriculture is under USA, and Brazil and Argentina accounts for 20.4% area each. As defined by FAO, conservation agriculture maintains a permanent or semi-permanent organic soil cover. This can be a growing crop or a dead mulch. Its function is to protect the soil physically from sun, rain and wind, and to feed soil biota. The soil microorganisms and soil fauna take over the tillage function and soil nutrient balancing. Mechanical tillage disturbs this process. Therefore, zero or minimum tillage and direct seeding are important elements of conservation agriculture. A varied crop rotation is also important to avoid disease and pest problems in conservation agriculture. So what exactly is conservation agriculture? Sustainable farming system based on three principles. That means conservation agriculture has three principles. First one is crop diversification. It decreases pest, disease and weed pressure. The second is minimal soil movement, which comes from the benefits of minimal soil movement comes from reduced tillage, either minimum or zero tillage. It avoids compaction in soil surface sealing, reduces erosion, reduces greenhouse gases. As when we do less tillage than conventional tillage, it cuts the amount of greenhouse gases produced in agriculture. It also improves soil fertility and structure, increases biological activity and soil organic matter, and less water and wind erosion happens in conservation agriculture, whereas soil temperature is also buffered. The third principle is soil coverage with residue of the previous crop or cover crop or both. It results in higher water infiltration and increase in water content of soil, also less evaporation. So Conservation agriculture is based on the interrelated principles of minimal mechanical soil disturbance, permanent soil cover with living or dead plant material, and crop diversification through rotation or intercropping. It helps farmers to maintain and boost yields and increase profits while reversing land degradation, protecting the environment and responding to growing challenges of climate change. To reduce soil disturbance, farmers practice zero tillage farming, which allows direct planting without plowing or preparing the soil or repeated plowing of soil. The farmer seeds directly through surface residues of the previous crops. Zero tillage is combined with intercropping and crop rotation, which means either growing two or more crops at the same time on the same piece of land or growing two different crops on the same land in a sequential manner. These are also core principles of sustainable intensification. Now, FAO has determined some goals of conservation agriculture, and as per FAO, the goals of conservation agriculture can be listed as: it aims to conserve, improve and make more efficient use of natural resources through integrated management of available soil, water and biological resources combined with external inputs. It contributes to environmental conservation as well as to enhanced and sustained agricultural production, and it can also be referred to as resource efficient or resource effective agriculture. Now, these are the differences or major differences between conventional agriculture and conservation agriculture. In conventional agriculture, cultivating land using science and technology to dominate nature. Land is cultivated using science and technology to dominate nature, but in conservation agriculture, there is least interference with natural processes. In conventional agriculture, there is excessive mechanical tillage and it results in soil erosion, whereas in conservation agriculture, no-till or drastically reduced tillage is practiced. In conventional agriculture, high wind and soil erosion happens, whereas wind erosion and erosion through water is reduced in conservation agriculture due to soil cover. Residue burning or removal of residues, previous crop residues is a common practice in conventional agriculture, whereas in conservation agriculture the residues of previous crops are retained on surface, or the surface is permanently covered with any crop. Water infiltration is low in conventional agriculture, whereas it is high in conservation agriculture. There is use of XC2, FYM and compost in conventional agriculture, whereas in conservation agriculture, use of in situ organic manures and composts are practiced. Green manuring is also practiced in conventional agriculture, which can be XC2, but in conservation agriculture here also cover crop is followed for covering the surface of soil, or brown manuring of green manuring crop in situ is followed. Again, in conventional agriculture, established weeds is killed, but it also stimulates more weed seeds to germinate. But in conservation agriculture, weeds are problem in early stages of adoption, but slowly with time it decreases. The problem of weeds decreases. Freewheeling of farm machinery and increased soil compaction is a major problem of conventional agriculture, whereas in conservation agriculture there is controlled traffic, compaction in tramline, no compaction in crop area, monocropping, monoculture and less efficient rotations are again a problem of conventional agriculture, whereas in conservation agriculture more diversified farming with more efficient rotations are followed. Heavy reliance on manual labor and uncertainty of operations are the problem of conventional agriculture, whereas in conservation agriculture the operations are mainly mechanized and it ensures timeliness of all the operations. Poor adaptation two stresses, yield losses are greater under stress conditions in conventional agriculture, but as there is more resilience to stresses, yield losses are generally less under stress conditions in conservation agriculture. Productivity gains in long run are in declining order, whereas it is just opposite. That means productivity gains in long run are in incremental order in conservation agriculture. Now these all the characteristics of conservation agriculture match with sustainable agriculture mainly, and we can sometimes think that sustainable agriculture and organic farming are same, but there is a difference between organic farming and conservation agriculture. Although the intercropping, crop rotation, mulching and cover crops all are followed in organic farming also, but there is difference. Conservation agriculture and organic farming both maintain balance between agriculture and resources. Both of them use crop rotation and protect the soil organic matter. However, the main difference between these two types of farming is that organic farmers use plough or soil tillage, while farmers who practice conservation agriculture use natural principles and do not till the soil. Organic farmers apply tillage to remove weeds without using inorganic fertilizers. Conservation agriculture farmers, on the other hand, use permanent soil cover and plant seeds through this layer. They may initially use inorganic fertilizers to manage weeds, especially in soil with low fertility. Over the time, the use of agrochemicals, fertilizers may be reduced or slowly phased out. Now these are the prospects of conservation agriculture. Reduction in the first benefit or prospect of conservation agriculture is a reduction in cost of production. Most studies showed that the cost of wheat production is reduced by rupees 2,000 to 3,000 due to saving on account of diesel, labor and input costs, particularly herbicides. Reduced incidence of weeds, as most studies tend to indicate reduced incidence of Phalaris minor, a major weed in wheat, when zero tillage is adopted, resulting in reduced use of herbicides. Saving in water and nutrients. Most studies have suggested that there is up to 20 to 30% of water saving under zero tillage condition, and also there is when crop rotations and soil cover is followed, there is also saving of nutrients, in external nutrients. The fourth one is enhancement of soil quality, that is soil physical, chemical and biological conditions all are improved under conservation agriculture. Increased yield. Conservation agriculture has been reported to enhance the yield level of crops due to associated effects like prevention of soil degradation, improved soil fertility, improved soil moisture regime due to increased rainwater infiltration, water holding capacity and reduced evaporation losses, and crop rotational benefits. However, these benefits of increased yield are not shown in earlier years when the crop conservation agriculture is newly adopted, but these the effect of increased yield is prevalent in slowly or gradually with time. Now there are environmental benefits. Conservation agriculture involving zero tillage and surface managed crop residue systems are an excellent opportunity to eliminate burning of crop residue which contribute to large amounts of greenhouse gases like CO2, CH4, carbon dioxide, methane, nitrous oxide, etc. Burning of crop residues also contribute to considerable loss of plant nutrients which could be recycled when properly managed in soil. Large scale burning of crop residues is also a serious health hazard. Enhancement in the long term carbon sequestration and build-up in soil organic matter constitute a practical strategy to mitigate greenhouse gas emissions and impart greater resilience to production system through climate change related aberrations. Conservation agriculture also results in advanced sowing date, as there is less time is needed for preparation of next crop or preceding crop. Especially in case of rice wheat system, when zero tillage or reduced tillage is followed in wheat condition, wheat crop, then almost 10 to 15 days of time, which is very crucial in case of rice wheat cropping system, is saved, because no field preparation is required. So the wheat is planted on the optimum time of sowing, and delaying sowing of major crops. Most of the crops results in very heavy reduction in yield, especially in case of winter crops and wheat. The other benefit is crop diversification opportunity. Cropping sequence, rotations and agroforestry system, when adopted in appropriate spatial and temporal patterns, can further enhance natural ecological processes. Resource improvement also, surface residues acting as mulch, moderate soil temperature, reduced evaporation and improved biological activity. Improvement of resource use efficiency through reduced residue decomposition, soil structural improvement, increased recycling and availability of plant nutrients. But as we all know, when any new technology is coined, then there are some pros and cons of each technology. So there are some constraints in conservation agriculture also, as it is heavily dependent upon farm machinery. So these are the constraints. First one is lack of appropriate seeders, especially for small and medium scale farmers. Although significant efforts have been made in developing and promoting machinery for seeding wheat in no-till system, successful adoption will call for accelerated effort in developing, standardizing and promoting quality machinery aimed at a range of crop and cropping sequences. These would include the development of permanent bed and furrow planting system and harvest operations to manage crop residues. The next one is the widespread use of crop residues for livestock feed and fuel. Especially under rain-fed conditions, farmers face a scarcity of crop residue due to less biomass production of different crops. There is competition between conservation agricultural practices and livestock feeding for crop residues, as the crop residues are retained on surface of soil, so there is less feed for livestock. There is a major constraint for promotion of conservation agriculture under rain-fed conditions. The next is burning of crop residues for timely sowing of next crop and without machinery of sowing under conservation agriculture system. Farmers prefer to sow the crop in time by burning the residues. This has become a common feature in rice field system in northern India, and this creates environmental problems for the region, the whole region. Next one is lack of knowledge about the potential of conservation agriculture to agricultural leaders, extension agents and farmers also. This implies that the whole range of practices in conservation agriculture, including planting and harvesting, water and nutrient management, disease and pest control, etc., needs to be evolved, evaluated and matched in the context of new systems. The next one is skilled and scientific manpower. The lack of skilled and scientific manpower. Managing conservation agriculture system will call for enhanced capacity of scientists to address problems from a system perspective and to be able to work in close partnership with farmers and other stakeholders. Strengthened knowledge and information sharing mechanism are needed. So these challenges or these constraints of conservation agriculture are to be focused and taken as challenges. These are the challenges conservation agriculture faces. The first challenge is understanding the system, because managing these systems, the conservation agriculture system efficiently will be highly demanding in terms of understanding the basic processes and component interactions which determine the whole system performance. For example, surface maintained crop residues act as mulch and therefore reduce soil water losses through evaporation and maintain a moderate soil temperature regime. However, at the same time, crop residues offer an easily decomposable source of organic matter and could harbor undesirable pest population or alter the system ecology in some other way. The next challenge is building a system and farming system perspective. A core group of scientists, farmers, extension workers and other stakeholders working in partnership mode will therefore be very critical in developing and promoting new technologies for considering the whole system, the whole farming as a system. The next one is technological challenges. Adoption of these practices under varying farming situation is the key challenge. These challenges relate to development, standardization and adoption of farm machinery for seeding with minimum soil disturbance, developing crop harvesting and management system. The next one is site specificity. Adapting strategies for conservation agriculture system will be highly site specific, yet learning across the sites will be a powerful way in understanding why certain technologies or practices are effective in a set of situations or not effective in another set. So it will always be needed that very site specific technologies for conservation agriculture are developed. The last one is long-term research perspective. Conservation agriculture practices, for example, no tillage and surface maintained crop residues result in resource improvement only gradually and the benefit comes about only with time. In many situations, benefit in terms of yield increase may not come in early years for evaluating the impact of conservation agricultural practices. Understanding the dynamics of changes and interactions among physical, chemical and biological processes is basic to developing the improved soil, water and nutrient management strategies. Therefore, research in conservation agriculture must have a long-term perspective. So, to cope up with these challenges, and to go to farmers with these technologies will make farmers to adapt conservation agricultural technologies for sustainable agriculture, and which is the need of the time. Thank you.